We start today 30th lecture and it's on fast decoupled load flow method. Before we go for this lecture, we just had a minor one, the test one. I have distributed the copies. Some of the ideal answers I will try to give. The slack bus, why do you select a slack bus? What is an importance? As you all know, there is only one slack bus. The rest of the buses are either PQ or PV. Now when you say slack bus, it is only one in number. Now this is also called reference bus. It is also called swing bus. If you remember all three names, you could have answered this question. Rest of the bus angles swing with respect to this bus, or rest of the deltas right from delta 2 onwards delta n are referred to slack bus, which is normally numbered as 1 delta 1, and this is also called sometimes as 0 degree. Not necessary, no loss of generality by assuming it to be 0, otherwise let it be 5 degree and some bus can be 45 degrees, so angle between them is 40 degree. Now this is one reason why you have to have a slack bus. Second thing, the losses. Losses are not known till the end of the solution. So you have to have a bus, preferably the biggest, the largest unit in a system, preferably located centrally, not necessary. If you have a state like UP and you have a Singrauli power plant which is not located in the middle of the UP, doesn't mean you will not have a slack bus as Singrauli super thermal power station. But it is always better to locate it centrally so that the distance travel to feed that power is minimum. Less the distance, less will be the losses. So this is the reason why you have a slack bus, that is to satisfy portion of the losses and to give as a reference bus, because rest of the buses swing with reference to this particular bus. This is the importance of slack bus, and the requirements are: it can be the largest bus, it can be centrally located, largest generator attached to the bus. These are the two requirements and this is the importance. Now what is the advantages of GS method? When you say GS, Gauss-Seidel, this is not just with reference to Gauss. Most of you have given the advantages with reference to only Gauss. No, even with respect to NR, even with respect to FDLF, you remember we drew the table comparing various methods with attributes. And in that, if you recall, GS needs minimal storage. Minimal storage. It is not only Gauss, even with respect to FDLF and with respect to NR. Why minimal storage? There is no complicated equation, there is no matrices, it is just a plain equation. Vik plus 1 is equal to Vik 1 upon Yii Pi minus Jqi upon Yij minus sigma Vi Yi up to k minus 1th bus, the latest values, after that the one iteration earlier values, because we have not computed them for this particular iteration. I hope you are understanding. We have come up to 4th bus, so 1st, 2nd, 3rd will be the latest values, 5th, 6th, 7th will be the earlier iteration values, because they are just not available. This is the most important advantage of GS is it needs minimal storage. There is hardly anything to store. The second biggest advantage of GS method is any fool will be able to program it. You don't need any knowledge because there is hardly anything to program. It is not a complicated programming, no inversion required, no triangularization, no back substitution, etc., etc. So this is the second biggest advantage of Gauss-Seidel is it is simplest, anybody can program, programming is very easy, it needs minimal storage, and these are the advantages you should have given, and you did not talk about its disadvantages because it is not asked. Whatever is not asked, you should never give information more than required, whether it is a courtroom, whether it is a viva, whether it is an interview, because we should be crisp, we should be to the point in all this, in whole life. You should not speak more than what is necessary, unless until you are among your friends and all those things. That's a separate issue. And the last was write SLFE. I think most of you have written correctly in polar form, barring few who have forgotten to write minus sign in QI. You need to have a minus sign for second equation. Some of you have not written, and some of you have done other some silly mistakes, but by and large SLFE have been properly written. Now we come to today's thing. If you recall, we were talking about fast decoupled load flow method. Now this method was first given by Brand Stott, a professor at UMIST, University of Manchester of Science and Technology, Institute of Science and Technology. Manchester is about 3 hours from Heathrow Airport. This was given in 1974. Why did he give this method? At that time, the computer was in its infancy. In fact, the first computer was invented, I told you, in 1948 by 3 British scientists working in UMIST, again, Manchester, where you have that ground of Old Trafford where you play test matches, where I think Farooq Engineer used to play his county matches way back. I don't know whether you were born at that time. I'm talking about 71, that was 70s was the era. So why there was a need to evolve or work on such a method? The Jacobian has to be inverted every iteration. So that from baby computer we came to calculating board, slide rule, analog computer, digital computer. The Gauss-Seidel method came in 1956 by 2 gentlemen called Ward and Halley. Then came Newton's method by Tinney and his associates in BPA, Bernoulli Power Administration. This is a power company in US, and Tinney and his associates gave this Newton's method. Then came decoupled method again by Stott in 73, and 74 he gave fast decoupled. He was not quite happy with only decoupled, right? What was the need? So the Jacobian becomes constant, and once your once your Jacobian becomes constant, you have to invert it only once, because in every iteration no changes take place. Once it becomes a constant matrix, there is no point in inverting it again and again. You are still going to get the same answer. But this has to be done by physically justifiable assumptions, so that only one inversion is required. So once J becomes constant, triangularization also has to be done once for each solution, a method given by B. Stott. What are these physically justifiable assumptions? Now I am going to list them. As all of you know, the angle delta at which we operate is small. Why it is small? I will tell you. P is proportional to sine delta. EV by x is constant. This is called P max. Why it is constant? P versus delta. So this is P max. Right? EV. V is fixed. V is fixed. This is the transmission line. This is V, this is E, and this is X. Once transmission line is fixed, X is fixed. Voltage at the receiving end is fixed. Voltage at the sending end is fixed. So P max is constant. Now this P max occurs obviously when sine delta is 1. And sine delta is 1 at delta is equal to 90 degrees. But we don't operate at delta is equal to 90 degrees because it is dangerous. You are standing here, Mount Everest. Slight distortion, slight fluctuation, slight perturbance will throw you down. So you are critically stable here. Since some of you are control students, you must have studied stability in control systems. You have a critically stable system. Your marginally stable system. There are several adjectives used along with stability. So it is better to be safe, and the safe is linear portion of this curve, and the linear portion goes up to 30 degrees. Sine 30 is how much? 0.866 root 3 by 2. Root 3 is 1.73 by 2 divided by 2. You get 0.867. Huh? 0.5. Sine 30 is 0.5. All right. Sine 30 is 0.5. All right. So why we are saying no? That's not the reason which I was giving. Sine 0 is 0. So sine increases very slowly. So it remains a linear portion. So sine delta can be put equal to delta for small values. Is this okay? For small values of delta, is it okay? So it becomes a linear, that is P directly proportional to delta, and that is why this is linear. I am sorry, that's not the answer. The answer is this. Why this is linear? I was trying to explain that. It is linear because P varies as delta as long as delta is small. So we operate somewhere here, 30 degree, and we are safe. So we come back to our original slide, and that is why when delta is small, cosine of delta is 1. It's exactly 1 at 0 degree, but for small it goes up to 0.86. This is 0.86. 30 degree cosine is which is very close to 1. 86.6% you get A grade. 99% also you get A grade. So as far as your grading system is concerned, 86 is same as 99 or 100 for that matter. And that is why perhaps Stott was knowing about our grading system. He says this is equal to 1. The reverse sine of that small angle is close to 0. This is very nearly equal to. And hence Gij, G is conductance. Sine of delta Ik is much less than Bik. And similarly Qi is less than Bi Vi square. What is this? Where do we use this? This is an expansion of Hik, Lik, Nik, Jik. You may ask me, what is this H, L and J? We never talked about it. This is the sub-matrices. When we write this Newton-Raphson method, delta P, delta Q, H, N, J, L, delta V. If you recall, we didn't use H, N, J, L. What did we use? We used delta P by delta, delta P by delta V, delta Q by delta, and L was delta Q by delta V. But if you are fussy, you don't want to do more work, then you can replace those derivatives, first order derivatives, because Jacobian was defined as the matrix whose each element is first order derivative of something. Delta P by delta, delta P by delta V, delta Q by delta, delta Q by delta V. And this some authors Some experts replace it by H and J, L. H and L are diagonal submatrices and J and N are off-diagonal submatrices. Now, this is the full expansion of H and L and N and J for Newton-Raphson method. But when you use these assumptions, they get simplified considerably simplified, and you just get Vi, Vk, Bik minus Bi, Vi square. Now we can make further assumptions that V also remains more or less near to 1, which is a fact. V is supposed to vary between 9.95 to 1.05 per unit. I think all of you know this curve. We should vary in this range, and once we crosses this, there is a penalty, and penalty will be steep as you cross more and more these limits. You have to pay penalty. Some electric companies now penalize you, private ones, because the moment V goes below 0.95 or above 0.105, you start using compensation. And those of you who are in control systems, they understand what is the meaning of compensation. You all the time talk of compensation, lead, lag, and so on. Similarly, power system people also talk of compensation, but this is a different variety of compensation. It's not lead, lag or lead, lag. This compensation is capacitors, a bank of capacitors, a bank of inductors. Where do you put this bank? I will show you where do you put this bank. This is the generator. This is transmission line. This is load, bus number 1, bus number 2. From here starts PS and QS, sending and real power, sending and reactive power. By the time it reaches load end or receiving end, they become PR and QR. Why they become? There is on the way losses. Any practical line will have a resistance, and anywhere where there is a resistance, there will be losses. Even if resistance is 0, some physicists do consider this as a lossless line. Electrical engineers don't, but physicists, yes. If you read field and waves theory in Jordan's book, if at all you do your IAS and engineering services and somewhere, you should have to read that book. And distortionless line, and lossless line, there are chapters physicists read. Even if the R is 0, X is there. If X is 0 means you are talking in vacuum. If nothing is there, then how do you interconnect? So far there is no wireless transmission in power systems. It may be there in microwave and telecommunication. You have those cell phones and even cordless landline. You can perhaps within 1 furlong or within few hundred yards, you can move around and talk. But you will never see that you can transmit power from IIT Delhi to Connaught Place without any link, without any transmission line. Forget about Connaught Place. Even the substation near bank to your hostel, I don't think you can transmit power without wire. Wireless transmission of power system is not yet possible. So you have to have losses. In that case, PS and PR and QS and QR will be different. By different, I mean they will be lower than this, because you are going to lose something, you are not going to gain something. And hence, once PR and QR reaches this end, There is load sitting here. Otherwise, if there is no load, no need of any power system. If there are no students, no need of IIT. What is the use of IIT when you all go away in summertime? Of course, IIT, as a Bombay, never sleeps. So similarly, IIT never rests. There are PG students, there are PhD students who all the time come and talk to the teachers. That's why teachers are here in summer vacation also, because there is a business for them. Now I'm using the management terminology, Our business is we are dealing with you. And that's why we are here in summer. So if there is no load, all electrical engineering courses will be closed, at least power system. Because no load means no generation required, right? Since load is there, we are all there as a power engineers, even control engineers. Load keys defined as PD and QD. PD is a real power load or load demand. QD is a reactive power load or reactive power demand. You have both. They are friends, hand in hand, together. Now, PD should be equal to PR. Then there is no problem. Whatever is the real load, real power comes, beautiful, excellent arrangement. Whatever are your expenses, if your scholarship is tuned to your expenses, what else you need? You tell us what are your expenses this month? Okay, this is your scholarship. Only danger is you can go on increasing your expenses. Your visits to Priya or Connaught Place will increase. So, should we increase correspondingly scholarship? Perhaps one day the authorities will say enough is enough. This is a fixed scholarship now. But suppose it is possible, then why not? Similarly, whatever is your load, if you have that much generation available, nothing is required. Beautiful arrangement, coffee break, no need to work. Unfortunately, the nature is not so accommodating. You get problems in life. Life is not a bed of roses. There are always some problems in everybody's life, and you have to tackle them. Some sickness, some bad news, all these things keep on occurring all the time in life, everybody's life. And the challenge is, the thrill is in tackling them head on rather than running away, like suicides, like leaving the program in between. If you're getting a foreign offer, then leaving, that's a separate thing. You're going for a bigger job. If it is not, what do? We go to AGC. This is a control system. Automatic generation control. Some people used to call it LFC or even ALFC, automatic load frequency control. What is that? Normally the generation will be less in Indian conditions. Here everything is less, nothing is more. Number of phone connections less, number of houses people own are less. Most of us live in rented accommodation as a tenants. Most of us try to borrow money. There are very few people who give money. Borrowers are more than the lenders. So normally in Indian system or in third world system, the load is always more than the generation. So what do? We try to increase the steam output by controlling the governor. And as long as we are able to increase the steam input to the turbine, the more power will be generated. And the moment this balance is established, PR is equal to PD, we stop increasing the steam input. This is called load frequency control. Frequency is back to 50 Hertz. So delta F versus time, deviations becomes 0. Here where your control system comes, P controller, PI controller, PID controller. In P controller, it is not necessary that steady state error will be 0. there may be a finite error, delta F, still left. But PI controller will ensure that your delta F with time will tend to 0. The moment it enters that 5% zone, we say it is okay, it is safe. Now, suppose this is not possible. You have tried your level best. No more further increase in steam input possible. Physical problem. Gate opening in hydropower corresponding to steam input. You are opening the gate. You open the full gate. Then what else is left? Nothing else. No further opening. You are going in a car. You want to hurry. How much speed? 100 km per hour or 60 miles per hour. Beyond that, you are at risk. You may not be there. Then who will reach there? The destination. So it is advisable not to cross certain limits in life. So the speed limit can be only increased to that extent which you can sustain, which your car can sustain. Similarly here, you cannot go on having, it will be flood. It won't be power generation, it will be flood. So there comes the concept of load control, load management, energy management, and there where your control knowledge will be useful. While control system people are doing this course, there is a method in madness. It's just not like that. Or maybe somebody might have said, oh, energy course is very easy, they give good grades or whatever. No, there is a meaning. Control system techniques can be very easily applied to power systems. So here you try to, that's called load side management, demand side management, which is a very important area in energy studies. There are institutions, full-fledged, World Bank, IGDR, Indira Gandhi Development Research Institute in Goregaon, near Film City in Bombay, where Kirit Parikh and Jyoti Parikh, they were there, and people are working round the clock on these problems. Demand side management. How to control this load, how to shift this load somewhere else so that the proper generation is there. Nothing else. Then you do what Indians do. What they do? Load shedding. 2 hours, no light. So load has been curtailed. So whatever generation is available, we get tuned to that rather than we control the generation. So we can't control. We have limited resources. That's what a poor man does. He forgets about one time food. He takes only once, or no dal or no sabji, something like that. That's load shedding, equivalent to load shedding. Only VIP areas will be served. Only hospital will be served. Only educational institutions will be served. And the major casualty will be domestic load, because they know the people have now inverters. Earlier we used to use lanterns or candles. So this is the whole idea about LFC. But there is another fellow sitting here, Q. We have not talked about Q at all. Q means voltage control, VR and Vs. If whatever is QD here, let me change the color of the pen. Whatever is QD here, if you can supply QR, no problem, no voltage problem, like no frequency problem there. This Q is connected with the voltage problem. Voltage will remain VR, whatever you want, as long as you ensure that your QR is equal to QD. I think we can change the page, otherwise it becomes too much of a mix-up. As long as this QR and QD are equal, your VR is okay. You remain between 0.95 per unit to 1.95. But as I said, the nature is not so accommodating. This QD and QR are never equal in Indian system. And if it is low, that means QR is lower than QD, the voltage sags. Moment you start another bulb in your room or your house, you can feel, you can sense dimness in light. Have you ever seen that? Especially if you start an AC, the big load, you will feel the difference immediately. Light will be slightly dim because the extra load has come. The Q requirement has gone up, and if you don't have that much Q, the only way the nature adjusts itself is the voltage sags. But if it sags with below limit, then there is a problem of voltage stability, which is much bigger than angle stability. The stability which you have studied in undergraduate is angle stability, P delta curve, swing equation, how the machines swing with respect to each other. Is delta is increasing without bound, that is an unstable region. Are you going more than 90 degree? Unstable region. So you have to come back, you have to see equal area criterion. Okay, all these things you must have done. Runge-Kutta method, modified Euler's method, compute, draw the table before fault, after fault, before, all those things. Voltage stability or voltage security is much more serious problem today in India than angle stability. And the first book in voltage stability came in 1994 by Taylor. It's available in library. Those of you who are interested can read it. So how do you make it equal? You do by compensation. Bank of capacitors. And this is QC. And then apply Kirchhoff current law here. QR plus QC should be equal to QD. So this you are importing extra help, borrow money. Some months your money is short, you have friends, you have some relative, local guardian, and can you give me some money, I am short, I will give you next month from my fellowship. So this is the, you are borrowing this reactive power from external to your system. Voltage stabilizer along your TV set, voltage stabilizer along with your AC. What for? So that your AC doesn't go bad. 20,000 worth rupees investment. Color TV, 15,000 worth investment will go bad if you have no voltage stabilizer. But don't think always QR will be less than QD, like a blood pressure. You can have a low blood pressure. The blood pressure required is 80, 120. Normally people become 90, 130, take a lot of salt, take a lot of sweets, all junk food, pizza, lot of cheese. Not your generation, my generation. You will not feel it today, you will feel it tomorrow, and sometimes that will be late. So you have to be very careful and avoid 5 white poisons. What are 5 white poisons? Salt, sugar, ghee or butter, the egg, the white part of it, and rice. Because till the chapatis come, there is a tendency in the hostel to go on taking rice. Even if you are not a rice eater like South and Bengal and so on. Anyway, this is medical thing, I don't have to talk about this here. Let us come back to this blood pressure. So sometimes they can get 70 to 110, more dangerous than 90 to 30. This is high blood pressure, this is low blood pressure. This is equally dangerous. So high voltage problem and low voltage problem, both are equally dangerous. The voltage coming 170, that is sag, but voltage becoming 250, the bulb becomes too bright, it will go, fuse. And that's a Faraday effect when there is a low load, light load conditions. You may have a condition when QR is more than QD. This is equally bad as QR is less than QD. Both are bad. If this situation occurs, what do? You have not switch off, that is not the way. That is like suicide. We have bank of inductors. Okay, and this will take some reactive power, absorb. So what is this extra will go here? Leading wires, lagging wires. Capacitors generates, this inductors absorbs, so that the voltage remains nice VR. This is called voltage control problem. And this is bank of capacitors and bank of inductors. But this is a static compensation. And this is not the end. How do you control the amount of capacitance and amount of inductance? Through solid state control, thyristors. Those of you who have studied power electronics, drives in undergraduate, they know very well what is a thyristor, PN junction. Now to control thyristor means you have to control firing angle. How do you control firing angle? Through computers, through microprocessors, and hence this gets automatically controlled, and the whole system is called SVS, static var system, or SVC, static var compensation. Of course, nowadays you have bigger things coming in the market called FATS, flexible AC transmission, which is full-fledged course in electrical engineering department. I think Professor Bhim Singh is teaching, or somebody is teaching. Earlier Professor Sanjay Roy used to teach, who is now happily sitting in Pittsburgh. So I think we have come to 1 o'clock, and we'll continue our story with FDLF and others next Tuesday. Any difficulty so far, whatever we have done today? Now we have understood what is this is the real heart of power system. That is the voltage, frequency, how do you control it, and that's where you will need your control system. Of course, nowadays there is intelligent control, smart control. Nobody is non-smart today. Everything is smart card, smart window. Nobody is non-smart. Our generation, everybody was non-smart. Now today's generation, everybody is smart. So smart control, the fuzzy logic, genetic algorithm, neuro-fuzzy. For American Indian, Indian American, neuro-fuzzy, fuzzy neuro. Thank you, gentlemen.